So, today's lesson is called Similarity Transformations. We are talking about dilations today. A dilation is a transformation that either enlarges or reduces the original figure proportionally. The scale factor of dilation, often used a variable k for that, is the ratio of the length on the image to a corresponding length on the pre-image. If you have a dilation with the k greater than 1, which means your scale factor is greater than 1, it's an enlargement, so it's going to get bigger. A dilation with a k value between 0 and 1 is a reduction, so it'll get smaller. So that might be a fraction like 1/2 or a decimal like 0.5. Okay, so down here, the directions say, determine whether the dilation from A to B is an enlargement or a reduction, then find the scale factor of the dilation. So first thing, is it an enlargement or a reduction? Remember, A is where you start, and B is where you end. And then we have to find the scale factor. So look at number 1. A is the start, B is the end. Did the triangle become enlarged, bigger, or reduced, smaller? This one is an enlargement. The triangle got bigger. To find the scale factor, we're going to find matching sides on the little and the big, and we're going to take the new shape and divide it by the old shape. So in this case, it's going to be like the B shape divided by the A shape. So on this triangle, the easiest side to tell the length of is the bottom. The bottom of this one is 3, and the bottom of this one is 6. So if you do the new number, 6, which is on the B, divided by the old number, 3, this gives us a scale factor, which is 2. And this matches with the enlargement because the scale factor is greater than 1. That makes an enlargement. All right, take a look at number 2. We're starting with shape A. We're going to shape B. Is this an enlargement or a reduction? This one is a reduction. It got smaller. So to do the scale factor, we're going to say new divided by old, which is B divided by A. And we need to find a pair of sides that's easy to count. Looks like B has a bottom side of 3 here. And A has a bottom side of 1, 2, 3, 4, 5, 6. So this one is 3 over 6, which is equal to 1/2 if you simplified it, because you divide by 3, divide by 3. So the scale factor is 1/2, which matches the idea that this is a reduction because the scale factor is between 0 and 1. All right? I think that you should pause your video, try number 3 and number 4 on your own, and then press play to check and see if you got it right or wrong. On number 3, this one, it starts at A and it goes to B. So it got smaller, so we call that a reduction. And the new number divided by the old number on the B shape is the new one. It's 1, 2, 3, 4 for the top side. And on the A shape, which is the old one, it's 1, 2, 3, 4, 5. So 4/5 is the fraction that is the answer for the reduction scale factor. And then on number 4, we start with A, we go to B. This one is also a reduction. Surprise, surprise. Okay, so the scale factor would be the new shape, which is the B shape on top, which 3 looks like a good number here. And the old shape, top side is 4. So 3/4 is the reduction scale factor. All right. Now, the next set of problems says, graph the original figure and its dilated image. Then verify that the dilation is a similarity transformation. So they give us points to plot, and then we have to make a graph. So that's what I'm going to do. Looking at the points, let me see if I can get this showing and the graph paper showing at the same time. Maybe. Number 1, the biggest number I see in any of these parentheses, positive or negative, is 5. So I'm just going to make sure that for number 1, my graph is big enough to go up 5, down 5, left 5, and right 5. That way I'll for sure have room to plot all my points. Okay, so we're going to plot these points. A is at -4. I'm going to have to scoot this up. Let's see. The challenges of making videos, getting all the information on here. -4, -3. This is point A. B is at 2, 1, 2, 3, 4, 5. And C is at 2, -1, 2, 3. So this is my first triangle, ABC. Okay. And then the next triangle has -2, -2 for D. E is at 1, 3. And F is at 1, -2. So here's my other shape, okay? So are these two triangles similar? Well, how do we know? Well, we do have for sure a right angle here on both. So we have one pair of angles that are the same, but it's difficult to verify these other angles. We can look at the side links. The right side here, we counted out 1, 2, 3, 4, 5, 6, 7, 8. And this side is 1, 2, 3, 4, 5. The bottom side is 1, 2, 3, 4, 5, 6. And this one is 1, 2, 3. So if we set up a proportion, little over big, 3 over 6 equals little side 5, which goes with big side 8. And we check to see if those are equal fractions. Let's see here. Those sides are proportional. 3 divided by 6 is 0.5. And then we're checking to see, does this equal 5/8? So 5 divided by 8 is 0.625. These are not equal fractions, which means these are not similar triangles. If they had been equal fractions, we could have said, yes, these two triangles are similar by side, angle, side, side, angle, side, because the two sides and the angle in the middle would have been, well, the two sides would be proportional and the angle in the middle would be congruent. But since the sides are not, pardon me, not proportional, we cannot use side, angle, side here, and we're going to say that they are not similar triangles. They're pretty close. 0.5 and 0.6 are not off by much, but they are not similar. All right, so for number 2, looking at the coordinates, it looks like the biggest one is 4, so we don't need a very large graph for that. Let me scoot this just so you can see what I'm doing. Go right here. Okay, so we're going to plot our points. -4, 1 is P. -2, 4 is Q. 0, 1 is R. 1, -1.5 is W. Oops, let me scoot this up a little more. 2, 0 is X. And last 3, -1.5 is Y. Okay, so now I just need to connect these points to make the two triangles. Oops. Now it looks to me like these two triangles are isosceles triangles because if you'll remember when we studied isosceles triangles back in the fall semester, we talked about how if one point is equidistant from the endpoints of the segment, it falls along the perpendicular bisector of that segment, it splits this into two congruent triangles, and that means this side and this side would be the same, which means it's an isosceles triangle. Same thing going on over here. But we don't know how long all these sides are. The bottom side is easy. This is 4 if you count over, and this is 2. So it looks like we could have a scale factor of 2, that it's the big one is twice as big as the little one. But we need to check these other sides to see if they follow that. And if they do, if all the sides are proportional, then these would be similar triangles. So let's use the distance formula. We haven't used that in a while. We learned this in the fall semester. Distance is equal to the big long square root of x2 minus x1 squared plus y2 minus y1 squared. So let's find the distance from P to Q. P is at -4, 1, and Q is at -2, 4. So we'll label the points x1, y1, x2, y2, and we'll put them in the distance formula. So PQ is going to equal x2, which is -2, minus x1, which is -4, squared, plus new parentheses, y2, which is 4, minus y1, which is 1, close parentheses squared. And we're going to type this in the calculator. So square root of -2 minus -4, close parentheses squared, plus new parentheses 4 minus 1, close parentheses squared. And this gives me, rounded to the 10th place, 3.6. Okay. Now I just found the length of this side PQ. I want to find the length of the side that corresponds to it on the smaller triangle, which is WX. So we're going to go W is at 1, -1.5, and X is at 2, 0. So x1, y1, x2, y2, we're going to go WX is equal to big long square root, start with x2, which is 2, minus x1, which is 1, squared, plus y2, which is 0, minus y1, which is negative 1.5 squared. And now we are going to put that into the formula. Square root of 2 minus 1 squared plus 0 minus negative 1.5 squared. And that gives us 1.8. Okay, so let's check the proportions here. The big one is 3.6. Whoops, y'all can't see that. And the little one is 1.8. So if I set up a proportion, little side 2 goes with big side 4. Little side 1.8 goes with big side 3.6. Are these proportional? And keep in mind, this is also 3.6 and this is also 1.8. So 2 divided by 4 is 0.5. 1.8 divided by 3.6 is also 0.5. So the ratio, the scale factor, is taking the big shape, multiplying it by 0.5 to get the little shape. And that works for all three sides. So we can say, yes, the two triangles are similar by side, side, side proportionality. All three sides of one triangle multiply by the same number to give you the side lengths in the other triangle. That number is 0.5. That is the scale factor from the big triangle to the little triangle. Okay, that concludes our lesson for today. Hopefully y'all do awesome on your assignment. Please let me know if you have any questions or you need any help, and have a great day. Bye for now.